Hello, Calculus. This is the opening of class for Thursday, October 1st. The topic is from average velocity to instantaneous velocity. And last class on Wednesday, we did a little work about computing average velocity, and we talked about this trip to Boston. So imagine this graph is like what we call a position graph or position function, and it starts on the left at time is zero and position is zero. So I start from my house and I'm driving to Boston. And imagine this is kind of unrealistic, but I'm on the highway, and at the starting time I'm already driving down the highway, and then when I get to Boston, it's just like when I pass a certain spot 120 miles away. So actually, when I made this up, it was a trip to Mike's Pastry in Boston. I don't know if you know Mike's Pastry, but it happens to be almost exactly 120 miles away from my house, and it's a fantastic place. Go there if you can. But the point is that to calculate velocity, we need to look at the change in distance over the change in time. So the change in distance from point zero, my house, to Mike's Pastry in Boston is 120 miles. So that's on the y-axis. So the change in y is 120 minus 0. And then the change in x, the change in time, on the x-axis, it's just hours. So it's from 2 hours minus 0 hours. So the change in time is 2 hours. So to compute average velocity, we just take that 120 miles divided by 2 hours, and we get 60 miles per hour. Notice that also is exactly the slope of this line. Okay, so again, average velocity is change in distance over change in time. And I want you to get used to this notation. So the change in distance, this is saying plug in time of 2 hours into our function, and what is the y value? So what's f of 2? Minus plug in the time of 0 into our position function, and what is the y value? What is f of 0? So take the y2 minus y1, you could think of it as, or one y value minus another y value. That's the change in distance. Then the change in time is just the change from 2 hours. 2 hours minus 0 hours, change in time. Okay, so then you would just calculate all of that out, and you come to 60 miles per hour. And want to note that this change in distance over change in time is really the same as the change in y, change in the y values, over the change in the x values, which is, change in y over change in x is just the definition of the slope of the line. So when we're back here looking at the change in distance over the change in time, we're looking at the change in y over the change in x, which is just slope. So in this case, the velocity, the average velocity, equals the slope of the line. They're the same thing. It's rate of change. Okay, excellent. So then the question arises, well, how do you calculate average velocity on a curved line? If it's a straight line, I just have to figure out the slope, and I know how to find the slope of a straight line. But this is this kind of skateboarder scenario on question 4, the problem set 3, where the skateboarder starts at position 0 at the starting point and starts, kicking furiously on the skateboard to accelerate and increase their velocity, so that after 10 seconds of kicking furiously, they're now going much faster than they were at 0 seconds. So in my trip to Boston, it was a constant velocity. I was going 60 miles an hour the whole time. But that's not true for this skateboarder. This skateboarder starts out slow and then is going fast. So it's a lot trickier to figure out what the average velocity is. Now, last time we said we could draw a secant line between 2 points. So let's say we wanted to know the velocity between time is 4 seconds into the skateboarding activity, from 4 seconds to 12 seconds of accelerating and kicking furiously on the skateboard. So we could calculate the average velocity by knowing, okay, after 12 seconds, the skateboarder is 144 feet from where they started. So we could just do change in distance, 144 minus 16, that's actually 128. And that would be over the change in time, which is 12 minus 4 is 8. So 128 feet divided by 8 seconds is 16 feet per second. So the average velocity from time 4 seconds to time 12 seconds is 16 feet per second is the slope of this line. Okay, so we could do that. But now where we're headed is, what about the velocity right here? Not the velocity between 4 seconds and 12 seconds, but what is the actual velocity at a specific point at exactly 4 seconds? That's the question we're investigating today. So what is the velocity of this skateboarder at time t equals 4? So what is the velocity right here? Well, we said velocity is slope of the line, so we got to figure out a way, how do we calculate the slope of this curved line at this point? And that's where we're headed. So you see on the slides, you see on Google Classroom that there is a Desmos activity. You go to this active calculus to do preview activity 1.1.1. And then for homework, you're doing this, which is also on Google Classroom. Okay, so this was kind of the intro, the setup. Then you're going to go to active calculus and do this activity and think more deeply about this question. And we'll be moving towards getting an answer to this. What is the velocity of, how do you figure out the velocity at a specific point in time? And we call that instantaneous velocity. So that's where it's headed, calculus. I hope that helped. Thank you.